Good evening, ladies and gentlemen. This is your well-rounded math teacher, Mr. Picard. And we're going to work with 4-6 complex numbers. We're going to split this video up into two parts. First part being on complex number, simplifying square roots, and the second one imaginary numbers. So, okay, product and quotient properties of square roots. So square roots, basically, if you're multiplying a number underneath the square root, you can break it up into two square roots. When would you use that? So like if we have the square root of 12, okay, I might break that up into the square root of 4 times 3. And that would be the square root of 4 times the square root of 3. Well, the square root of 4 I know is 2, so this is 2 square roots of 3. And this is kind of how we simplify square roots. If there's a perfect square number factor inside, well, like 12 has 4, it's 4 times 3, we can take that out. Take that out of the square root. And just like fractions, let's say we had 9 over, I don't know, we'll say 5, square root of 9/5. You shouldn't have fractions underneath your square root, so we always split them up into square root of 9 over the square root of 5. That's kind of what we want to do. And the square root of 9 is 3, so this is actually 3 over the square root of 5. So one way to work with these. Now, we don't want these square roots, or another word for square root is radical. Because if you have like the square root of 7, that's a radical number. Radicals. So when I talk about radical symbol, that just means we're talking about the square root symbol. So anyway, reminder, simplified square root expressions do not have radicals in the denominators. So like that last problem, 3 over the square root of 5, we'd have to simplify this and get that radical out of there. I'll show you how to do that. And any number remaining under the square root has no perfect square factors for that number, and we kind of did one of those already. So I'm going to look at 50. We'll start breaking these down. Actually, I'm going to start off with this, like the square root of 6. No, let's go square root of 25. Everyone knows that's 5, right? But why is it 5? Because 25 is actually 5 times 5. So the square root of 5 times 5. Whenever you have two factors that are the same underneath the square root, you can pull that out of the square root as a root of 5. So when we're breaking these down, I think there's a couple of different ways to do them. You can just find perfect squares and take the square root of them. Or you can break it down to the prime factorization and take out pairs of factors. So like 50, that's 2 times 25. And that's 5 times 5. So I would rewrite this as the square root of 2 times 5 times 5. And I just take that pair. When there's a pair of factors that are the same, you can take that out. That's just like the square root of 25, and we already know that's 5. So that becomes root of 5 on the outside, and the 2, well, that can't come out, so it just stays inside there. So that simplifies down to 5 square root of 2. 45. What do we got? 3 times 15. And we just want prime numbers, all the prime numbers. That's usually what we break these down to. 15 is 3 times 5. I circle them because they're both prime. So this is 3 times 3 times 5. Well, can we take anything out of there? Yeah. There's a pair of 3s. That's like the square root of 9. And the square root of 9 is 3. So that becomes a root of just 1 3 on the outside of the square root. And that 5 now stays in there. So 3 square roots of 5. That's what 45 is, simplified as a radical. 128. That's 2 times 64. And we could keep breaking 64 down, but 64 is 8 times 8. So I'm just going to do a little shortcut on this one. 2 times 8 times 8. And I could break these 8s down. That's 3 2s, and that's another 3 2s. But basically, there's a pair of 8s. I take that out. That's 8 square roots of 2. Kind of a simple way to do it. You could break it down to its prime factorization like we did in these two, or you could just say, hey, there's 8 times 8 is 64. That's a perfect square. I can take the square root of it, and that becomes 8 on the outside. You can also do this with variables. X squared is actually x times x. Well, there's 2 x's there, so that becomes a root of x on the outside. So when we're dealing with numbers and variables, 25 that's 5 times 5. X squared is x times x, and a y to the fourth, that's 4y's. So the square root of that, what can I take out? I can take out a 5. I can take out a pair of x's, which is just x on the outside. There's one y, and here's another y. I'm going to take that out. Cleaning that all up, that becomes 5xy squared. And there you go. This one, I tell you what, I would just, for these problems, I would simplify it before I do anything. X squared divided by x, that cancels out because it's basically x times x over x. That cancels out one of the x's. I'm left with the square root of x over 1, or just the square root of x. Okay, what else do we got here? Okay, some more fractions. I don't want a fraction underneath the square root or the radical, so I'm going to break that up into the square root of 11 all over the square root of 49. Well, 49 is 7 times 7, so basically this is the square root of 11 over, well, square root of 49 is 7, so that's simplified. 32 and 81. Square root of 32, square root of 81. Well, I know the square root of 81 is 9, but the square root of 32, 32, if you break it down, that's 4 times 8, 2 times 2, those are both prime. 8 is 4 times 2, 2 is prime, and then 4, that's 2 times 2. If you do the prime factorization, you don't use the numbers that came from it, just the prime numbers. So there's 3, 4, 5 2's. So what can I take out of the top? There's a 2. I can take out another pair of 2's. Those are comes a root of 2 on the outside. And whatever's out there already, you're going to multiply it by whatever you take out. And this 2 stays in there. This is all over 9. 2 times 2 is 4, so that's 4 square roots of 2 all over 9. Okay, with this one, I'd probably simplify it before I did anything. I know 8 goes in here once. I know 8 goes into 32 4 times. So what I'm really looking at is the square root of 4x all over the square root of 1. Well, the square root of 1 is 1. So that's just the square root of 4x over 1, which is just the square root of 4x, basically. Now, 4 is actually 2 times 2. So I'm looking at the square root of 2 times 2 times x. I can't take the x out. There's only one of them, so it stays in there. But I can take those two 2's out. That's like the square root of 4, and the square root of 4 is 2. So it becomes a root of 2 on the outside. And the x stays underneath the square root, so that's 2 square roots of x. Okay, what do we got here? Square root property. For any real number n, if x squared equals n, then x squared equals... Okay, so this goes to the fact that, I'll just make one up. We'll go with 25 again, because everyone knows the square root of 25 is 5. But I need to have two answers here, because this is an x squared, this is a quadratic. If I take the square root of both sides like this, whenever I take the square of a square root, I got to consider that x could equal 5, or it could equal negative 5. So we just say plus or minus 5. Because negative 5 squared, guess what, is 25. And positive 5 squared is also 25. So when you do this, take the square root of a square, it's always plus or minus on the other side. Okay? So solve this using the square root property. Now this only works when you have an x squared and not an x. Because if I had an x here, equals, I don't even care, 0. I can't use the square root property because I can't deal with the x, because I can't take the square root of x and have it come out. So it's only when you're dealing with just an x squared in your equation. So like here, I just have an x squared. Here, I just have an x squared, no x. So solving this, get it by itself, add 25 to both sides. X squared equals 25, and then take the square root. The square root cancels out the square, and I'm left with x equals, Remember, this is plus or minus 5. For this one, it's just an x squared, so if I can get the x squared by itself, I can take the square root of both sides and get my answer. So I'm going to add 45 to both sides, and I get 2x squared equals, looks like 98. I'm not going to take the square root yet because I'm going to get rid of this 2 first. Excuse me, I just want the x by itself. So x squared equals 49. Now I can take the square root of both sides, and x equals plus or minus 7. That's the same as saying x equals 7 or x equals, I actually say and, because there's two answers, x equals 7. Okay, but you can just write plus or minus 7. This one's a little bit different because it is just an x, but this quantity squared. If I can get any quantity, x plus, well, I'll say h squared, if I can get it by itself, I can take the square root, and that cancels that out, and you're left with just the x minus h, or plus h. So I technically just want to get this by itself. So I'm going to add 12 to both sides, and I get x plus 2, that quantity squared, equals 25. That works out nicely. Take the square root of both sides. When I do that, the square root cancels out the square, and I'm left with x plus 2 equals, it's still plus or minus 5. So I'm not done solving for x now. Now I got to get x by itself, so I'm going to subtract 2 from both sides. I always do the plus or minus second. This cancels out. X equals negative 2 plus or minus 5. Well, negative 2 plus 5 is 3, so that's one answer. Negative 2 minus 5 equals negative 7. That's my second answer. That's what you would do with this problem if you get a perfect square here. Okay, let's do this last one. I'm going to subtract 48 from both sides on 3x squared equals negative 48. Divide by 3. X squared equals negative 16. Okay. So let's take the square root of both sides. Square root cancels out the square, and I get x equals plus or minus, okay, negative 16. You can't take the square root of a negative number and get a real answer, but you can, and we're going to talk about this in the next lesson, take that negative out, and that just becomes I square root of 4. But the square root of 4, if you take the square root of a negative number, it's what we call an imaginary number, and that's what we're going to get to. I'll show that in the next lesson, dealing with I a little bit more. But the square root of 4 is 2, so this is plus or minus I times 2. Well, the I it's kind of like pi. It's an irrational number. It just states that you took the square root of a negative number. How would I write this? Well, it's plus or minus. You kind of treat that like a variable. You just say 2i. Plus or minus 2i. So technically x equals 2i and x equals negative 2i. And they're both imaginary numbers, and that's it. You can do a little bit of work right now, or you can watch the next part of the video, imaginary numbers, and work on that section 4-6. We'll get back to you later. Peace out.